Round off rules. For the mean, median, and mid-range, carry one more decimal place than is present in the original set of values. And really don't worry about it. Pearson will tell you what to round to. For the mode, leave the value as it is without rounding, because when we find the mode has to be a value that really is in the original data set. Critical thinking. We can always calculate measures of center from a sample of numbers, but we should always think about whether it makes sense to do that. We should also think about the sampling method used to collect the data. Here's an example. See each of the following illustrations situations in which the mean and median are not meaningful statistics. The zip codes of the Gateway Arch in St. Louis, the White House, Air Force Division of the Pentagon, Empire State Building, and Statue of Liberty. That's what these are. These are zip codes. If I want to know what the mean is, I can add these all up. So let's write down what it is. The mean, we would add up 63102 plus 20500 plus 20330 plus 10118 plus 10004. There's 1, 2, 3, 4, 5 different zip codes. So I divide this number by 5. If I want the median, I put these numbers in order. So my smallest looks like 10004, then 10118, then 20330, then 20500, and then last 63102. Now, let's say I figure out what the mean is. I don't know what it is. And honestly, I'm not going to even do it. Why am I not going to do the mean? Because what does it mean? Like, what if the mean is 30,000? What does that have to do with anything about zip codes? It literally has nothing to do with it. I can calculate it because I have numbers, but it's meaningless what the number gives me. And the same thing is true for the median. If I want to find the median, I have 5 numbers. This number right here is the middle. It represents the Air Force Division of the Pentagon. What exactly does that give me? It's meaningless as a number, even though it is a number. We wouldn't add that with something else. And if we did, we would just get a different zip code, but it wouldn't have anything necessarily to do with where it is. Mean or the median are not meaningful statistics. And that's basically what this says. The zip codes don't measure or count anything. The numbers are just labels for geographic locations. So meaningless, right? How about this one? Ranks of national universities of Harvard, Yale, Duke, Brown, Dartmouth, and Brown. So I could say the mean is equal to 2 plus 3 plus 7 plus 10 plus 14 divided by 5. Can I do that quickly? 24, 31, 36. 36 divided by 5 is 7 1/5. What does that mean? 7 looks like Duke. What is 7 1/5? Well, it's absolutely meaningless. It has no significance. There's probably no one rated 7 1/5. Getting the mean doesn't help us any. If I want to find the median, 2, 3, 7, 10, 14. The median is 7, which we said is Duke. But what does that mean? We didn't include 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I mean, we only just picked random numbers. So the median, again, the fact that I get Duke as ranked number 7 as the median is meaningless to me. The ranks reflect an ordering, but they don't measure or count anything. And if you don't have this box and you want to use StatCrunch, find a problem that does. Open StatCrunch, because if you notice, StatCrunch is still open for me. I haven't closed it. I can use it for anything. But what I do want to do here is I want to use it because that way I don't have to type in the data, because it downloads all the data for me as well. Once I do that, I have all these numbers put into my form. And what I'm going to find is the mean, looking right here, the mean, the median, the mode, the mid-range. We're going to go to stat, summary stats, column. We're going to use var1, and let's make sure we get everything we need. I'm going to leave the count. I always like to know how many. The mean we do need. We don't need the variance. We don't need the standard deviation or the standard error. Let's see. Do we need the median? Yes, we do. Do we need the range? No. We do need the min and max for our mid-range, though. This we'll talk about another time. And does it ask me for the mode? Yes, it does. Well, let's get the mode as well. And I hit compute, and notice all my information's right here. Let's put that on this side, and we'll put this on this side. And now I have all my information handy. Right here, it says type an integer. An integer is a whole number with no decimal, or a decimal, which is what we have, rounded to 1 decimal place, which is one more than we have, which is exactly what our slide said. Our answer would be 44.3. If you're not sure how to round things, let me teach you real quick. 44.272727. If I want to round to the nearest 10th, this is the 10th place. I want to round to this number. I look 1 number to the right. If it's 5 or more, I round up. Less than 5, I truncate, which means I erase all numbers after that number, after the one I want. Here we have a 7, which is 5 or more. As I round up, the answer here would be 44 point, the 7 makes the 2 into a 3. I round up. What if I wanted to round to the 100th place? The 100th place is right here. If I want to round to the 100th place, I look at my 100th place, I go to the right one, that's a 2, which is less than 5. What truncate means, I would leave the 44.27 and I would just eliminate everything after that. And that is what I mean by truncate. The median is 33. And I'm just getting it right here. Median 33. Check answer. Good. The mode, no mode. Check answer. And the mid-range is the only one we'd have to do anything for. The mid-range is equal to the min plus the max divided by 2. Here we have 10 plus 97 divided by 2, which is equal to 107 divided by 2, which is 53.5. Okay, perfect. What do the results tell us? Well, we never actually read anything, did we? It says find the mean, median, mode, and mid-range for the data. And then E, which is what we're on, answer the given question. Well, let's find out what these numbers represent. Listed below are the jersey numbers of 11 players randomly selected from a roster of championship sports teams. What do the results tell us? What does 53.5 tell us about jersey numbers? It tells us nothing. The mid-range gives the average or typical jersey number? No. Since only 11 of the jersey numbers were in the sample, the statistic cannot give any meaningful results. Well, I'll go with the second half of that sentence, but it's not the reason why. The jersey numbers are nominal data and they do not measure or count anything. This is sounding good. So the resulting statistics are meaningless. That sounds about right. The mean and median give two different interpretations of the average or typical jersey number, while the mid-range shows the spread. No, I say C. Okay, perfect. Find the mean, median, mode, and mid-range for the data. I'm going to just click on here, open in StatCrunch. And we've got the values. It came with the values. And now we go to Stat, Summary Stats column. We select var1. And then we want the number. We want the mean. We want the median. Do we need the mid-range? Yep. So we need the min and max. And then do we need mode? Yes, we need mode. Compute. Okay. So there's everything. And the mean rounded to 2 decimal places. Here we have 9.9, which is 1 decimal place. We're going to add 1 more. The mean is 9.27 because I'm rounding to 2 decimal points. I look at the number to the right of the second decimal, and it's a 2, which means I just get rid of everything after the 7. Check answer. The median, 9. The mode, we do have a mode, and it's 8.6. Let's look. We have 1, 2. We have 3 8.6s, and I bet we don't have more than 3 or 3 of anything else. 8.6 inches would be the mode. Perfect. And the mid-range, remember, we have to add the min plus the max divided by 2, which is 8.6 plus 10.5 divided by 2, which is 19.1 divided by 2, which is 9.55. Check answer. Good. And let's see what we are looking at. Listed below are foot lengths in inches of randomly selected women in a study of a country's military in 1988. Are the statistics representative of the current population of all women in that country's military? Since the sample does not include men, the sample should not be considered to be representative of the population. No, because we're only talking about the population of women, so A is definitely not what we care about. Since the sample is not random, well, it is random. They told us it was randomly selected, but it's not B. Since the measurements were made in 1988, they are not necessarily representative of the current population of all women in the country's military. So far, I'm going to go with C. Let's read D. Since the sample is random and the sample size is greater than 10, okay, the sample can be considered to be representative of the population. I don't think that that is true. I think we would need more than 10. We can't really look back at 1988 to see what is happening 40 years later. Many things could have changed. since the measurements were made in 1988, they are not necessarily representative of the current population of all women in the country's military. They may have had different rules in those days for a woman in the military. Maybe you had to be a certain height. That would have more to do with it than anything else. We can't just make assumptions. We are going to have to find that little box. So I'm going to open this up and open it, the data in StatCrunch. We have our data. Let's see what they want us to do. The values are matched so that subjects each have systolic and diastolic measurements. Find the mean and median for each of the two samples and then compare the two sets of results. Are the measures of center the best statistics we can use with this data? What else might be better? I'm going to go to Stat, Summary, Columns. I can pick them both. And how do I pick them both? I pick it and I hold down the Control key and I click my mouse on the next one. What am I looking for? Well, I'll make sure I have the right number. We don't need variance. We don't need standard deviation. We don't need find the mean and median. It looks like that's the only thing we need is mean and median. And hit compute. The mean for the systolic is 129.7. And for the diastolic, 127 and 76.5. Check answer. The mean and median for diastolic are both lower. That's true. Let's click that. The mean is lower for the diastolic, but the median is lower for, no, that's not true. The median is lower for the diastolic pressure, but the mean is lower for the, no, that's not true. The mean and median appear to be roughly the same. That's not true. And let's see, the mean and the median systolic pressure are both lower than the mean and median for the diastolic. Well, no, that's the opposite. I stick with A. Let's check our answer. Perfect. Are the measures of center the best statistic to use with this data? Well, let's see. What do you think? Since the systolic and diastolic blood pressure measure different characteristics, only measures of center should be used to compare the data sets. Okay. Since the sample size are large, they're not large. We can eliminate that. Since the systolic and diastolic blood pressure measures different characteristics, a comparison of the measures of center doesn't make sense. Okay. We can go with that one. I think that one would be it. Since the sample sizes are equal, measures of center are evaluated to compare the data sets. Not necessarily. It really does depend on what we're measuring. We can't say just because the values are matched, we could compare the heights of men to the heights of horses. But is it meaningful? That's what we always have to look for. I'm still going to stick with C. What else might be better? Well, since measures of center are appropriate, there would not be any better statistic to use in comparing the data sets. Okay, because the data sets are matched, it makes more sense to investigate any outliers that do not fit the pattern of the other observations. No, I don't think that's necessary. Because the data are matched, it would make more sense to investigate whether there is an association or correlation between the two blood pressures. That I like. Since measures of center would not be appropriate, it would make more sense to talk about the min and max values. I don't think so. I like this one because they're matched, meaning they come from the same person. So they might have a lot more meaning. Because they're matched, we might get more information that's useful by knowing how each apply to the other, because these are from the same person. We'll open this in StatCrunch, summary stats column, var1, and here's our information. The mean is 406.12, median 200, perfect. The mode is 425. Excellent. The mid-range, we have to use our min plus our max divided by 2. Let's do that. We have 3,000 plus 49, my min plus my max, divided by 2. That number is 1524.50. Are there any outliers? Well, we have our data here, and 49, 70, I mean, these aren't too terrible. These aren't too terrible. All of a sudden, I jump from 425 to these two giant numbers, which really are skewing my information, isn't it? Because if I didn't have these two values, my mid-range would be in the hundreds, and here it's in the thousands. Are there any outliers? Yes, there are. These two appear to be outliers, these two right here, because they're just so much bigger than everything else. Check answer. And that ends 3.1. Thank you for watching.